This test, answer key review. The first question, how many significant digits are in the value 420,306 and 1? So we have 420,306,001. First, you know that all the numbers that are not 0 are significant. And then any zeros between two other numbers that aren't 0 are also significant. So that means that all of these digits are significant. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Your answer here should be C, 9 significant figures. Number 2. Which unit is determined by the distance light travels in 1/300 millionth of a second? Well, this goes back to your SI units, and if you don't have the definition memorized, you could look for the clue right here which says distance light travels. So the definition of distance in the system is meters. So your answer here should be A. All of these others, second is for time, gram is for mass, hour also for time, and that's not an SI unit, so you could eliminate those as well. Number 3. What kind of graph would be best for use with this data? So you have 3 types of graphs: circle graphs, line graphs, and bar graphs. And you want to look at what the data says. You've got different colors of M&Ms, and they're counted in terms of percent. Anytime you have a percentage of a whole, the best type of graph to use is a circle graph. So you should have A. Bar graphs are good for categories, so that doesn't count. Line graphs are for plotting points where you have 2 different types of data, which we don't have here. And so none of the above, also not a good choice. Number 4. Object has a mass of 51.40 grams and a volume of 6.528 cubic centimeters. What material is it likely to be made of? Well, none of these answers here are cubic centimeters or grams by themselves, but what we do have is the density, which is the grams over cubic centimeters. So we need to calculate the density, which is mass divided by volume, and then see if it matches one of these answers. In this case, we've got a mass of 51.40 grams divided by 6.528 cubic centimeters, centimeters cubed, and that comes out to 7.8737 and so on. There's some other numbers if you do it in your calculator, and that rounds to 7.874 grams per cubic centimeter, which is the mass that matches the one for iron. So your answer here should be answer B. Number 5. The product of 4 times 10 squared and 2 times 10 to the negative 10th centimeters expressed in scientific notation is one of the following. So the first thing you need to know is that the word product means multiply. So we're multiplying this number times this number, finding the answer, and then it's going to be one of these choices. So we have 4 times 10 squared times 2 times 10 to the negative 10th power. When you're multiplying or dividing 2 numbers in scientific notation, you multiply the coefficient. So 4 times 2 is 8. That's going to be the new coefficient. And then you add, because we're multiplying, we add the exponents. So 2 plus negative 10 is negative 8. So your new answer is 8 times 10 to the negative 8th. And when we look up here, that is answer choice D. There is the correct answer. Number 6. What kind of graph would be best to use with this data? Okay, so here we have another graph question, and the types are circle, line, or bar graph. Well, we don't have percentages or parts of a whole, so that rules out circle graph. Line graph is good for plotting 2 different values against each other. So we have amount of salt added compared to boiling temperature. So this would be a perfect situation for plotting points. You could draw a graph with salt on the x-axis and boiling point on the y-axis, and then you would get some sort of a line with the points on it. So that's a good case for answer B, line graph. Number 7. the accepted value for a quantity is 5.89. If the measured value is 5.67, what is the percent error? All right, so percent error equals the absolute value of the error divided by the accepted value times 100. So the measured value is 5.67, that's the experimental value, minus the accepted value, 5.89, gives you the error. Okay, the error in this case comes out to negative 0.22. So we take the absolute value of negative 0.22 divided by the accepted value, which is 5.89. We multiply that by 100, and it comes out to 3.74%. It actually comes out to 3.738 or 9, and so on and so forth. In this case, there was just a typo on the practice test, so you could have answered either C or D, and you would have been correct, 3.74%. Number 8. Which of these has only 3 significant digits? So let's count the significant digits. A has 1, 2, 3. This 0, because it's a trailing 0 after a decimal point, counts. That's 4 significant digits. 1, 2, 3, 4. Well, already that's too many, and that 0 doesn't count, but it's still 4. So that has 4. That has 4. This one has that 0 does not count. That 0 does not count. Any zeros to the left never count. 4 and 5 count, that's 2. A trailing 0 in a number with a decimal counts. There's number 3. So your answer should be C, but just to be sure, 1, 2, 3, and a trailing 0 makes that 4 significant figures. So your answer should have been C for that one. Number 9. How many significant digits are in the value 0.000340? Well, we know that none of the zeros to the left ever count, so we start here. 3 and 4, they're non-zero numbers, so those count. And this 0 is a trailing 0 or terminal 0 in a number that has a decimal point, so that counts. The total is 3, which is answer choice C. Number 10. Convert 600 grams to milligrams. So this is going to be dimensional analysis. So we start with 600 grams over 1 times. We want to put our unit of grams on the bottom. We're trying to cancel that out, and we're converting to milligrams. We put that on the top. And we know that 1 milligram is equal to 0.001 grams. Or you could have put 1,000 milligrams over 1 gram. But this is the way the chart in the book is set up, so I'm going to use that as an example. So then the grams unit and the grams unit cancel each other out, and we have 600 divided by 0.001, which makes the answer 600,000, and the unit is milligrams. Number 11. Put the following numbers into scientific notation and round to 2 decimal places if necessary. So putting them into scientific notation means there's only 1 digit to the left of the decimal. So for answer A, I'm going to move 1, 2, 3, 4 times to get 8.45. And then the exponent on the 10 is going to be a 4. And because I had to move, I had a decimal and I had to move to the right, it's negative 4. So 8.45 times 10 to the negative 4th. B, I have to move 1, 2, 3, 4, 5 places to the left, and I get 9.24 times 10 and 5. And because this was a big number, that's a positive exponent. C, you have to move 1, 2, 3 places to get 4.36. And since I moved 3 places with a big number, that's a positive 3 exponent. D, moving the decimal 1, 2, 3, 4, 5, 6 times to get 9.76, and I'm going to round off that 4, times 10 to the negative 6th, because I had to move, I had a decimal, I had to move it to the right 6 times. And finally, E, you have to move 1, 2, 3, 4, 5, 6. Don't stop here because you have to keep going. 7, 8, 9, 10, 11, 12 times, and you get 6.15, and I'm going to round off the rest of it. 6.15 times 10 to the 12th power, and since that's a really big number, I know that should be a positive exponent. Number 12. Convert the following to standard notation. So this is conversions in the other direction. So 5.1 times 10 to the third, and it's a positive 3, means I should have a big number. And the 3 tells me I need to move 3 places. So 1, 2, 3 becomes 5, 1, and then I have to fill in 2 zeros. That's 1, 2, 3 places I had to move that decimal point. 5.1 times 10 to the negative 4th power means I'm moving 4 places to the left. Because it's a negative, I'm going to end up with a decimal. So 0.00051, because I had to move it 1, 2, 3, 4 times. 7.35 times 10 to the negative 2nd means, again, I'm moving to the left, and I'm moving it twice, so I'm going to end up with 0.0735. That's 1, 2 moves. 5.2 times 10 to the 5th means 5, 2, 0, 0, 0, 0, because I had to move that 1, 2, 3, 4, 5 times to the right. Positive exponent, big number. 4.35 times 10 to the negative 4th, negative exponent means it's going to be a decimal, so I got to move it that way 4 times. 0.000435. I moved it 1, 2, 3, 4 places. Number 13. A student reports 3 trials to measure the density of unknown metal. The percent error in these trials is given in the table. So trial 1 was a percent error of 0.1, trial 2 0.05, and trial 3 0.07. The question is, which is the most accurate value from these 3 trials? Which trial was the most accurate? Well, the most accurate means you've got the closest to the right answer, and in percent error, the closest to the right answer would have the smallest percent error. So trial 2 has the smallest percent error, which means it's closest to the correct answer, the most accurate. Number 14. Convert 4,500 millimeters to meters. Here's another dimensional analysis problem. So 4,500 millimeters over 1 times, we're converting to meters from millimeters, and 1 millimeter is 0.001 meters. So if we cancel out millimeters, 4,500 times 0.001 is 4.5 meters. That's the unit that we wanted. Number 15. A student reports 3 trials to determine the density of an article and records the data shown. The accepted value is 2.55. Calculate percent error in each trial. Okay, so you have to do 3 calculations here. Remember, percent error equals the error, absolute value of the error, divided by the accepted value times 100. So for trial 1, the error is 2.45 minus 2.55, absolute value, divided by the accepted value of 2.55 times 100. For number 2, it's 2.65 minus 2.55 divided by 2.55 times 100. And for number 3, you've got 2.52 minus 2.55. Take the absolute value and divide by 2.55 times 100. So in the first trial, you've got 2.45 minus 2.55. That's comes out to negative 0.1. And we divide that by 2.55 times 100. We get 3.92%. Okay, that's the right number of significant figures, since we had 3 digits in all of our starting values. Number 2, you actually end up with 0.1 positive times divided by 2.55 times 100, and you get 3.92% again. So you have the same percent error, even though one was high and one was low. So you get two different errors, or 2 different answers that can have the same percent error. And finally, 2.52 minus 2.55 is negative 0.03 divided by 2.55, and that comes out to 1.18%. error. So again, if you were asked which one was the most accurate, it would be trial 3, which has the smallest percent error. Number 16. Convert 0.000789 milligrams to grams. Dimensional analysis again. 0.000789 milligrams over 1 times converting to grams from milligrams. 1 milligram is 0.001 grams. And so it's 0.000789 times 0.001, which comes out to 0.000000789 grams, because the milligrams and the milligrams cancel each other out. So you should have decimal point followed by 6 zeros, 789 grams. Number 17. Perform the following calculation and round to the correct number of significant figures. So first you have to add all these numbers together. If you add them together in your calculator, you get 12.2529. But you have to take a look back at your starting numbers and find the number with the least number of decimal places, which in this case is 2.25. It has 2 decimal places. So I have to go to 2 decimal places, and I'm going to round it off there, which means my final answer should be 12.25. Number 18, perform the following calculation and round to the correct number of significant figures. This is multiplication, so we multiply these numbers together and we get a really long number, which is 29.649309255. But we're not going to keep all those decimal places. We're not going to keep all those digits. Look at your starting values. In multiplication and division, you find the value with the least number of significant figures, which here is 3.55. It has 3 significant figures. So I have to round my answer off to the 3rd significant figure. 1, 2, 3. Round it off. My answer is 29.6. That has 3 significant figures. Number 19. Sample of strontium has a volume of 500 milliliters and a mass of 200 grams. What is the density? Well, it says right here, density equals the mass times the volume. So I can plug in, I've got a number for mass. Remember, grams is the unit for mass, so that's what's going to go on top. And milliliters or liters or cubic centimeters, those are volume. So that's going to go on the bottom, 500 milliliters. If I divide that out, I'm going to get 0.66 grams per milliliter. Make sure you keep those units in there. And question 20, last question. If a vessel contains 30 milliliters of water and a sample of 10 grams of copper metal dropped in the vessel, raising the water to 45 milliliters, what is the density of the copper sample? So another density problem, mass divided by volume. Here's the thing you have to keep in mind. I've got 2 volumes here, so which one am I supposed to use? Am I supposed to use 30 or 45? Well, the answer is neither, because what the question says is the vessel starts out with 30 milliliters of water in it. That's just the water. This is just what we did in the density lab. So if you have 30 milliliters of water and you add something to it and the water goes up to 45, that means your final volume is 45, your initial volume was 30, so the volume of the thing you entered into it is the difference between those 2 numbers, which is 15. So that's the volume. That's the number I'm going to plug in on the bottom. So I've got 15 milliliters, and up here, grams is mass, so that's 10 grams. That's the mass. So I divide that out, and I get 0.66 grams per milliliter. And I'm just realizing that I messed up the last question. The last question, I'm going to go back. So this is the answer for number 20. So for number 19, I did the math wrong. I was looking at the wrong answer on the answer key. 200 divided by 500 is not 0.66. 200 divided by 500 is 0.4 grams per milliliter. So sorry about that. That is the answer for number 19, and number 20 should be 0.66 grams per milliliter, and that is the end of the practice test.